Here's a rotifer, and you can see, so they have two sort of filter feeding tentacles on the end of them, and then they usually have an attach point where they're usually this is normally attached. They'll actually, you can see the water circulating through their mouths. This is a spectrophotometer, and so what we do every day is we run tests on our water to make sure that, you know, the parameters are where they're supposed to be, and we're not exceeding any levels in our permit. And so, so this is just one of the ways that we check on a regular basis, and then we record all of our data right here. And we use these vials, and all it takes is we get a sample of our effluent. So so a test like this is COD, which is the chemical oxygen demand of the water. So we just draw up some water like this, and then you put it into one of these vials, and these take a little bit of time to react. You set a timer for 2 hours, and then after 2 hours, you can take the vial and you just put it in this machine, and it automatically reads the barcode, and it sends light through, and then it gives us a result. So this is one of the things we do on a regular basis to make sure our effluent is good. Okay, this is our microscope that we use to look at our microorganisms on a regular basis. What we're doing is we're actually kind of counting and quantifying which organisms are more prevalent, and then we record their frequency here on this log every other day about. And what we're trying to do is we're trying to determine, you know, which organisms we see the most of. There's amoebas, there's crawling ciliates, there's stalk ciliates, there's rotifers, there's nematodes, there's water bears. And the organisms up here on the top in the orange category indicate a younger sludge. The organisms down here indicate an older sludge. And so we're really trying to determine how the health of our system, how old the sludge is, which tells us whether we need to waste more or build up our biomass a little bit more. And so the easiest way to do that is just to take a sample here. This is our settled sludge that's in our activated sludge basins. I'll just kind of continue. So we're going to prepare a slide of our activated sludge and look at these microorganisms. So and as you can see on the computer screen, I'm just going to kind of go through and look to see what we can find, and I'll point out some things of interest as we find them. So just we basically just pan the entire slide and look to see what is prevalent. So these brown masses are flocculated bacteria that are essentially our workers that are basically eating all the waste out of the water. These other organisms, such as these right here, these are stalk ciliates, and you can see they're sort of catching particles and consuming them. Those are a higher level organism that are just indicator organisms. They're not necessarily treating the wastewater, but the more of those that we see, the better the health of the system. So that's a good sign. So this was a free swimming ciliate right here, and they move around pretty fast. He kind of got stuck there, but he'll probably move here in a minute. But yeah, you can see him crawling around. We also see, like I said, there's amoebas, there's water bears, which are an actual older sludge, indicated much older sludge. But we do occasionally see those. This right here is a nematode, you can see this. You can see this big long worm with the bristles. That's a nematode. Stalk ciliates. There's another free swimmer there. Here's a rotifer, and you can see, so they have two sort of filter feeding tentacles on the end of them, and then they usually have an attach point where they're usually this is normally attached, but you can see he's moving around here. Let's find him again, because you can see they'll actually, you can see the water circulating through there. But I mean, there's you know, when we run a sample in the machine to see what a parameter is, like what is the ammonia level, or if there's you know, that takes time for the reaction to occur. But when we look at the microbiology, if all of a sudden we see everything is dead, that's a big concern, because that means that something has potentially toxic has came in and disrupted our microbiology, our biomass. And so it's another sort of cautionary check to make sure everything is looking good and normal. In addition to sort of determining the health of our sludge, we're checking for potential problems as well. So this is our dewatering press. And what's happening here is we're dewatering our biosolids, and we are producing a biosolids cake that is approximately 13% solids, and that is getting augured up into this dump truck. And we fill the dump truck, and at the end of the day, we go dump it in our storage facility. Those are our biosolids that the treatment plant produces on a regular basis. And so what they are is we have the activated sludge process that is full of microorganisms that are eating the waste out of the water. Well, these microorganisms reproduce, we get more and more of them. We control the population by wasting extra ones out of the system once they've done their job. And so we basically send those extra organisms up to this machine here. It comes in the consistency of chocolate milk, basically. And then the machine squeezes the water, most of the water, out of the biosolids, and what remains gets put up in the truck. It's a drier product that we can actually dump and scoop up with a loader. And the truck there shows that's about a day's worth that we've produced. Here we have, this is our biosolids cake, and you can see there's not much moisture in here. It is damp, but it's basically like a composted dirt type texture and consistency. This ultimately is what we're disposing of, and there's a couple different ways that we can do that. We can haul it to the landfill and put it in a landfill to get rid of it. We also have the option of land applying it as a fertilizer. It's spread onto cropland and incorporated into the soil, and it provides, you know, nitrogen, phosphorus, fertilizer to that soil. This is the very last step of the wastewater treatment process. We're re-aerating our cleaned water so that it has oxygen in it before we send it to its discharge point. So our reclaimed water, the water that we're treating and cleaning, gets aerated here, and then it basically goes into a lift station and gets put in a pipe for 5 miles, and it goes to the Big Sioux River and gets discharged right into the Big Sioux River. So that's where we're claiming it back to its natural use in the river.